In this video, we will learn how to solve a linear equation using the method of guess and check with the TI-30XS multi-view calculator. I've chosen the following example from a GED practice exam to show how we can use the calculator to identify where there is an error in solving the following linear equation. Notice that the original equation is 3 times parentheses x plus 6 close parentheses equals x plus 8 plus x. And we see from the problem that at the end, supposedly the final answer is going to be that x is equal to -2 after performing a series of algebraic operations on both sides of the equation. But how can we use the calculator to identify where the error took place? Well, we're going to do so in a pretty creative way. What I'm going to do is this. Let's assume that this is supposedly the correct answer at the end, x equals -2. What we're going to do is go backwards through each of these steps that were performed to see whether x equals -2 works as a solution on both sides of the equation in each step. And if we come to a point where it is not the equation solution, then we know that that step is where the error must have originally been made going forward. So let's go ahead and do that. First, I'm going to assume that x is equal to -2 and see whether x equals -2 works in step 3. And I can do that very easily on the calculator by doing the following. I'm going to take x equals -2. I'm going to store that in the calculator for the variable x. So I do that with the store button. I hit enter. Now -2 is stored in for x. And I only have to worry about evaluating the left-hand side of this equation in step 3 to see whether 5 times x is indeed equal to -10. So I can do that very simply. I type in 5x, I hit enter. That evaluates that expression on the left-hand side in step 3's equation. And we see that we do indeed get -10 equals -10. All right, so far so good. So this leads to this being correct. So I'm moving my way up. I started with this. That naturally follows that -10 equals -10. So going from here to here was okay. And -2 being the solution. Now I go to step 2 and I'm going to do the same sort of check. I'm going to see whether sticking in x equals -2 makes the left-hand side equal to the right-hand side, which is 8. And again, we can do that very easily on the calculator. We still have -2 plugged in for the value of x. So I'm going to type in 5x plus 18, and I'm going to hit enter. And lo and behold, the answer for that expression when x is -2 is 8. In other words, I have that 8 equals 8. That's a true statement. Again, that's assuming x equals -2. So from here to here, from step 2 to step 3 must be okay because x equals -2 works from those steps. And of course, going from step 3 to step 4 is okay because I got that -2 was the solution for step 3. So now we're going to step number 1. And we're going to see whether or not plugging in x equals -2 makes the left-hand side equal the right-hand side here. So let's see what happens there. I plug in 3x plus 18 into the calculator. I get a value of 12. And I'm going to go ahead and write that. So these go together. This is here. This is here. And now I have 12. Remember again, that's when x is -2. And now I'm going to do the same thing on the right-hand side of the step 1 equation. 2x plus 8. And let's see what that numerically is equal to. Well, oh, here we have something that doesn't work. This is not equal to this. In other words, 12 is not equal to 4 in step 1 when x is -2. That means that between step 1 to step 2, there must have been a mistake made because from step 2 Backwards to step 1 is when I see that x equal -2 doesn't work, so since we're really trying to solve the equation going downward, then step 1 to step 2, in other words, step 2, there must have been an error made algebraically that led to an incorrect solution. Now before I close, let me very quickly show how this would have been done algebraically so that we can see that what I've done numerically using the calculator and working backwards actually does match how we could have done this algebraically. So here's the original equation. The first step, step 1, would have been to combine like terms and apply the distributive properties. So 3 times x would have been 3x. 3 times 6 would have been 18. And I would have had that equal to combining like terms, 2x plus 8. We can see indeed step 1 was originally correct. Step 2, if I had solved this correctly, would have consisted of bringing the 2x to this side and doing a subtraction leading to x, and then I add the 18 and equals 8. And I can see indeed in step 2 there was an error made. I have 5x plus 18 equals 8 in the problem statement. It should have been x plus 18 equals 8. So whether we do this numerically working backwards as I just showed, or if you are able to do it algebraically, we get the same result that the error was in step 2.